Hey everybody, I am showing you today a lab. We're going to be doing lab number 13 and I'm going to be showing you all about conduction. This lab will be readily available to you on Microsoft Teams, so if you open up your Teams assignment for the day, you will see the conduction lab posted there. I figured because it was a remote learning day that it might be easier for you guys, considering that all the classes are kind of condensed, and of course seeing that they're all on a different time schedule, it might be easier for you guys to do this via YouTube with a pre-recorded lesson about it. So what you guys have previously learned in the lesson right before this one is that there are three methods, three ways in which heat can be moved or transferred from one thing to the next. And the first way that we discussed was through the process of conduction. And conduction is heat transfer through direct contact. What you need is something that's hot, that has a lot of potential of energy. And when it touches something that doesn't have as much energy, through direct molecular contact, conduction takes place. Conduction really works best in solid materials, so if you have something that's solid touching something else that's solid, or some type of connection through a solid material, you find that conduction usually takes place the best. Conduction is a totally slow process. It's not like the heat just flies from what's hot into what's not. It really doesn't happen that way. But as this lab, as we talk about this lab, you're going to see that. The second way that we talked about in which heat can be transferred is something called convection. Convection is heat transfer through these circular cells. Basically, you have these circulation cells where warm stuff rises because it's less dense and cool stuff sinks because it's more dense. And convection happens best within fluids like water or within air. So convection is more related to like water or like the atmosphere. The last and final type of heat transfer that we discussed was something called radiation. And radiation takes place best through empty space. That's where something like the sun, the energy from the sun would travel through empty space where there's no material, no medium there. And the energy basically travels through empty space and can basically heat things up many millions of miles away. So today's lab is going to be based on the first type of heat transfer, which I said is conduction. Once finished with this lab, we actually will do convection and radiation. So here's the deal. Conduction lab, what you want to do is just get to it in your Microsoft Teams. You're going to fill out the name. Let me go with today's date. So I'll just kind of squeeze some stuff over here so I can get my writing pad. So today's date, or whatever date that we're doing this on, I believe this is going to be on the 18th of December, but whatever date that you're completing it on, of course, you're going to fill in my name as you always do. So you can just put my name in here, which is going to be Corso, period, whatever period you have me. The lab number is going to be lab number 13. Minutes is something that I take care of, so you don't have to worry about filling that out. So let's get right to the introduction. So here we go. Introduction. Where there's a difference in temperature between any two objects or regions in contact, I want you guys to underline that word. Energy will be transferred from the high potential. High potential basically means just from the hot item. So whatever has more energy is going to be moved from what's hot into what's not hot, which is what we mean by low potential. So I want you to think of high potential as, in this experiment, it's going to be the hot cup. And I'll explain this to you in a little bit, a little bit further. And low potential in today's experiment is going to be the cold cup. And again, if you're not quite sure what I'm talking about yet, in a couple seconds from now, it's going to become very clear. Now, this process by which energy moves from something that's hot into something that's cold is known as conduction. So let's underline that. Now, while some heat is released from the Earth's interior, most energy is absorbed at the Earth's surface from radiant energy from the sun. Conduction of heat, as I mentioned, is a very slow process. Energy that moves from something that's hot to something that's not hot, it doesn't take place quickly because typically, like I said, it's traveling through a solid material and the energy takes time to travel when it's going through a solid material. Now it says, however, conduction is a significant process in transferring heat between the Earth's surface and the air in contact with the Earth's surface. Objective, in today's lab, you'll be able to measure and explain heat flow by means of conduction from one region to another. So let's get these vocabulary terms filled in, and then we're going to get right to this. So for conduction, your definition, your appropriate definition should be the transfer. Oops, sorry about that. The transfer of heat from the hot object. And most of the time when we refer to something that's the hot object, we call this thing the heat source. So in parentheses next to hot object, I want you to write heat source. The source of heat, obviously it's the hot thing, right? So the transfer of heat energy from the hot object, the heat source, into the cooler object, or you can write the cold object, either one. And the cold object or the cooler object we're going to refer to as the heat sink because heat sinks into it through direct contact. So we need that direct molecular contact. We need the hot thing to be in contact, physically touching the colder object. Okay? And again, conductions, if you want to kind of just draw an arrow off here, you can say to yourself or write down, can take note, okay, that it happens best in solid materials. Okay, so it happens best in solids. Like I said, convection is a different type of heat transfer. That happens best in liquids and gases, that phase of matter. Radiation, like heat from energy from the sun, that takes place in like basically no type of medium, no solids, liquids, or gases. But conduction, it's definitely the choice of heat transfer in solid materials or solid matter. Now, for rate of change, we can just simply copy down from the reference tables the formula. So if anybody is not aware of the rate of change formula, again, you can always turn to your reference tables and simply just copy down the formula for rate of change. That's going to be the change in a value, and that's going to be divided by time. So again, change in value divided by time. We're going to today look at how temperatures change over time. So we'll probably do some subtraction between two temperatures, divide the amount of time it took for that temperature to change. And again, rate of change is just a simple mathematical calculation. Now, down here, we're going to define conservation of energy. And conservation of energy is just as it sounds. It means to conserve energy. And to conserve energy means to trap or to save energy somehow. So we'll write to trap or to save energy in some way, shape, or form, right? To trap or to save energy. In our houses, we trap and save energy a lot. We close windows, we close doors, we put insulation in the walls and in the roof. All these are means of keeping heat from flowing, obviously, out of our house into the outside. Okay, saves money when you do that. So we're definitely into conservation of energy. Oops, sorry about that. Let's flip back. Hang on. Silly machine here. Okay, so let's get back to where we need to be. Very sensitive mouse. It decides to do whatever it wants to do. So let's go back to notability. There we go. So as I was saying, what we're going to do now is we're going to look at the procedure part of this lab. And what it shows you is some equipment. And I actually brought the equipment home for you so you could see like live what they're showing you a still view of. So let me just exit out of this so I can see where my screen share is going on here. And I want you guys to realize, I'm just like I said, I'm going to just make this a little bigger for now. Let's see if I can make that bigger. What you guys are going to see here is I have two styrofoam cups. It's really kind of easy to see. And what I do have inside of the styrofoam cups is two thermometers sticking out of the top. One cup has been labeled as the cold cup because we're going to put cold water in it. And the other cup is labeled as hot cup because we're going to put some hot water in it. And again, we got two thermometers. If I tilt it towards you, you can see that these two cups are in contact. The contact between them is made through a metal bar. Okay, and what's going to take place is I'm going to take off the two lids with the thermometers and the metal bar. I'm just going to take them out of contact for a second. Okay, I'm going to take this contraption and just lay it down. And for my cold cup, what I'm going to do is I'm going to transfer. I basically measured out equal amounts of both cold water and hot water. So in this insulated mug, while I was doing the vocabulary, I just have some cold water, obviously some ice cubes in there. I'm going to get equal amounts, so I filled that up, like I said, about 3/4 of the way, a couple more ice cubes in there, right? And I got cold water sitting in my, basically my styrofoam cup. And then of course over here in my other insulated cup, I got some steaming hot water. So let's just take the lid off of this carefully as not to spill it. Okay, and all I'm going to do is equal amount. You guys can see, I don't know if you can really see it in the screencast here, but it's definitely steaming. Okay, so I'm just going to pour that hot water in there. Okay, equal amounts. Okay, both cups have the same. Again, one's just got hot water, the other one's got cold water. And what's going to take place, okay, is I'm going to basically connect these two cups with the metal bar, right? And of course, we have two thermometers which take the temperatures. We also have two styrofoam lids, foam lids, basically to help trap or conserve the energy within the cups. So we put these back together, right? And what we would normally do, non-COVID year, okay, is we would let these two sit, and every minute for about 20 minutes, we would actually read the temperature of both the hot cup and the cold cup. And what we would find over time, okay, is as these cups sat in connection together, as they conducted energy from one to the next, the heat would actually, let me see if I can tilt my monitor down just a teeny bit more. I don't think I can. But what would happen is the heat would start in the hot cup here. It would travel across the bar, which I can already feel it heating up over here. The heat's coming up. It's going to go across the bar. It's going to be transferred through the solid material, and it will eventually heat up the cold cup. So the hot cup will lose its energy through the bar, will travel up the bar, across the bar, and down into the cold cup, and actually raise the cold cup's temperature over time. But remember what I said in the beginning of this lab as we read the introduction, conduction is not a fast process. So the hot cup is going to lose quite some temperatures, quite some heat, energy. Probably it's going to lose a lot of it to the surrounding air before it actually even gets to travel across that bar and somewhat warm up the cold cup. Okay, but again, non-COVID year, we'd actually be doing this class and touching equipment, but right now, we're not. So you get to see it as such. So now, if I flip back to the actual lab, okay, as you see right here, okay, we had the two cups, and again, imagine, if it kind of color codes it, this would be, let's actually make this a red. I intended to make that red, but it was still black. So let's go up here. This would be, okay, again, filled in with your hot water, right? And again, if we write this down, we can make an H. Sure, it says hot water right here. But again, if we were to shade this all in, this would be your steaming hot water, right? And of course, on the other side, you've got connected to the hot cup or the hot water, your aluminum bar, and it connects into your cold cup. And we'll just kind of color code that so you remember that this one is the one with very low potential energy and it's got a lot of cold water in it. Now, as we sit here and we watch the experiment, if I took temperatures every minute, okay, we would see, okay, that the hot cup would begin to lose energy because it would go across, come out of this thing. Again, the hot water, we often refer to this as the heat source. So heat source. And the energy would be conducted, it would be transferred up through the aluminum bar, across the aluminum bar, and it eventually go down the aluminum bar into, again, this cold cup, which we call the heat sink. Now, don't be fooled. Okay, as the energy is traveling across, not all of this hot energy is going to make it across into the cold cup. A lot of it will actually be lost through radiation to the air. Okay, and if this, hot cup ended up losing, just make up a number, 20 degrees and got colder by 20 degrees, this cold cup would not gain all 20 degrees. Again, it's a very slow process, so as the heat's traveling across the bar, some of it's actually escaping into the surrounding area. Okay, so that basically was what would normally happen. We'd watch this in person. So what it says here is fill the insulated cups with cold and hot water, boiling water, quickly replace the lids. When the thermometer in the hot cup reaches its highest point, you start recording. Normally we would take the temperature readings for both the cups at 1-minute intervals for about a total of 20 minutes. And then what we do is we would construct a graph to show this. So if you guys look, right, on the following page of this lab, you have data. You've got a time, it says 0 minutes through 20 minutes. And then what you've got is temperatures of your hot cup. And then you've got temperatures related to your cold cup. And what they want you to do is plot both the hot cup and the cold cup on the graph below. So you're going to have 2 lines actually running across your graph. And what sometimes people need a little help or a little assistance with is setting up the graph in a way that, the data would look presentable and, it's read easily. So I'm going to set the graph up with you. And once I'm done setting up the graph, I would recommend that you pause this video and you graph. And then once you're done graphing, you would go ahead and answer the remaining questions. So here we go. You ready? We're going to go down here. We're going to put time. Okay, so we're going to put time in minutes as your label for your x-axis. Okay, your x-axis is the one that's cutting across the bottom. We're going to start at 0 minutes, and each line that you jump over to the right can increase by 1 minute. So 0 minutes, 1 minute, 2, 3. This would keep on going. 4, 5, 6, 7, 8, 9, 10, 11, 12. This guy here is going to be 13, 14, 15, 16, 17, 18, 19, and 20, right? We don't need to go past 20. And then on my y-axis, if we refer back up to here, right, we just did the time in minutes across the x-axis. My y-axis is going to be my temperature in degrees Celsius. And again, you're going to be plotting both rows of data. So you're going to have 2 lines, okay, a hot cup line and a cold cup line on your graph. I would do one at a time. I wouldn't try to plot both. So like start with the hot cup, you'll do all this data, and then do your cold cup and do that data. So here we go. Temperature ranges, your coldest temperature in your cold cup was 22, your hottest temperature in your hot cup was 98. I'm pretty sure there's about 20 lines. So if you do about as high as almost 100 divided by 20 lines, if you go by 5s, I'm pretty certain it works out. So let's just make sure we got this. So temperature in degrees Celsius will be your y-axis. And where x meets y, let's make this 0 again, and let's go by 5s. So this would be 5 degrees, 10 degrees, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, that should be 8, 85, 90, yep, works out perfectly, 95, and 100. So all we have to do now is just make up a little key, and we're going to plot. So like in other words, like a key, I would do something like this. I'd be like, okay, I'm going to do my hot cup. I'm going to plot my hot cup in red. So off to the side, this will be my hot cup color. And then you can choose, like I said, any color you really want for your key. Let's make the blue, this different color blue, my cold cup color. Okay, here's my little key that tells me which one's which, and then you just start to plot. So if I go back to my red color, whichever one I chose, I think it was that one. Okay, go back to my data. We're going to start here at 0 minutes. Your hot cup was 98. So at 0 minutes, which is here, 0 minutes, I'm going to go up to 98 degrees. 98 would be like just basically under 100. Okay, and then I'm like, okay, that data is done. I personally like to kind of cross things off as I go, or at least put a check mark so I don't lose my spot. After 1 minute, you're at 93 degrees. So again, 1 minute here, you're going to go up to 93 degrees, which would be about there, right? And what you want to do, like a lot of people actually kind of sometimes forget or they save it to the end, is you want to connect as you go. That's a terrible line, but you get my point, right? So you want to connect as you go. That way you don't have any confusion on how you're connecting these. Okay, so once you are done, okay, let's see if I can erase that terrible first line. Okay, once you are done doing this, what you're going to have to realize is that once you're done plotting the hot cup, right, all the data from here down, okay, you're going to start on your cold cup. So your cold cup is going to start at the bottom of the graph. Obviously, it increases in temperature because it's getting heat from the heat source. Okay, remember that cold cup is where the heat sinks into it. We call that cold cup the heat sink. So again, you get your blue colored pencil, whatever your crayon, whatever you got at home. You can use your, if you're doing this remote, digitally, you just pick a color like I did. And you're going to start at 0 minutes 22, at 1 minute 22, and so on. So again, 0 minutes, you would go up to 22. You make your first dot. At 1 minute, it was stayed at 22, so you make your second dot. And again, connect the dots as you go. So again, you're going to see a general decrease in your hot cup. You're going to see a slow increase in your cold cup, and you'll have your plotted graph. Now, once you're done with your plotted graph, like at this point, I would probably pause the video, or actually the video is not going to be too much longer, so you really don't have to. But once you're done with your plotted graph, your job is to answer the discussion questions. So you'll see on your final page of your lab, very straightforward discussion questions. You're going to use the information from the lab, okay, to answer that. A lot of things are often a lot of the questions are often spoken about or read about in the introduction. So you want to go back to here. That will help you, or your notes, or even the pictures, or this video. You could always go back. And the only thing that you might need a little assistance with is number 9. But when we go over this lab, I will help you on rate of change in case you guys had a difficult time or any type of challenge with, putting the numbers into the formula right. But you can always refer back to the vocabulary for that formula and see if you can punch in the numbers and get it right. I'll give you a hint though, for rate of change for number 9, you'll be taking 2 numbers, you will be subtracting them, and you'll divide by 10 minutes. Okay, the first number will be the number at the start. The second number will be the number of that hot cup or that cold cup at the 10th minute, okay, the temperature of it, and then you'll divide by 10 minutes. So that should be pretty straightforward. When you're done with that, last 3 questions, and you are done with another lab. So hopefully this video was helpful to you. It was only about 24 minutes, 23 minutes and a half. Like I said, hopefully this helped you out. Always remember that the hot cup in our experiment is known as your heat source. The heat will be transferred across this bar up and over, and the heat will eventually get to the cold cup, which we call your heat sink, and that all happens through direct contact from this bar, this aluminum bar, by the way. I don't know that I mentioned that that's aluminum, and that heat will go across through that contact that is being made through that aluminum bar. It'll do it very slowly. So conduction is a slow process, as mentioned, okay? So hopefully this lab was pretty easy for you, and hopefully this video helps. I'll definitely be checking in with you throughout the day. If you have any questions, you can always shoot me a message or ask me in the meeting. And that's it for now, guys. All right, take it easy. Have a good one.